Hey guys, someone asked for some help with some homework problems, so I'm going to jump right into it. This is page 104, number 7 and 8 as these. You're supposed to find the central angle here. So your new best friend is this equation here, s equals r theta. S is arc length, r is the radius, and then theta is the radian. So we're not dealing with degrees anymore. If you have degrees, you're just going to convert them into radians, and that's what you did in the last section. Okay, so if I look at number 7, right, I want s equals r theta. So I do know what s is. S is the arc length. Arc length is literally the distance that you walk around the edge of the circle. So if you are imagining taking a walk on a circular track, if you started here and you walked to here, you went 3, whatever these units are, we don't know, but okay, so in my equation, s equals r theta, I'm just going to pop in a 3 for s. The radius was 3, and then I'm solving for theta. So in this case, I'm just going to divide both by 3. That means theta is just 1 radian. Okay, and units are kind of important here, so you want to remember to stick them on, because we're not dealing with degrees. Okay, and then you do the same exact thing for 8. There's 8, so we're going to plug in 6 for s. R is 4, and now we will solve for theta. So just divide both sides by 4, and you get 3/2, or 1.5 radians. Okay, so that's it for 7 and 8. 36 is super hard, but kind of cool. So that's this car speedometer one. And very interesting. I don't know if you've ever thought about it in real life, changing out your tires. If you change the radius of your tire, it does have an effect. So let's see what effect it has. So first thing that we need to do is figure out, okay, well, let's just look at A, right? Find the number of rotations of a tire in 1 hour if the car has driven 55 miles per hour. So first you need to think, okay, if I've driven 55 miles an hour for 1 hour, how far did I go? Didn't you go 55 miles? So that's kind of where I need to keep 55 miles in my head, right? So for 36, I know the car traveled 55 miles at the end of the day, or at the end of the hour, right? Okay. The other thing I need to know is when the car does 1 rotation, how far did it travel? So when it just does 1 cycle through. So that, guys, is basically circumference, isn't it? So remember the formula for circumference is 2 pi r. Okay, they told us that our tire has a radius of 14 inches. So we'll just pop in a 14 for r. That means my circumference is 28 pi inches. Okay, you can turn that into a decimal if you want. I'm not even going to bother here until the end, but you could. So then you could say, okay, my car, if I do 1 tire rotation, it went blank inches, whatever that number is. Okay, but what I need to do is figure out, okay, I want to know how many times did it rotate if I kept it going for 55 miles. So the best way to do this is to use our dimensional analysis. So I know in 1 revolution, I'm going to go 28 pi inches. Those two are equivalent. 1 revolution, I'm going 28 pi inches. They're the same thing. I want to convert this now, right? I'm trying to figure out how many revolutions I do in 55 miles, right? So I need to get from inches to miles. Well, I don't know exactly what that conversion is, but I know that in 12 inches creates 1 foot, and then 5,280 feet create 1 mile. Do you remember doing this dimensional analysis stuff where I wanted the units to cancel? So I'm putting 1 on the bottom, 1 on the top, so that inches will cancel with inches, feet will cancel with feet. So if I were to stop right now, it would tell me how many revolutions I do in 1 mile. But that's not what I want. I have 55 miles to go, so I'm just going to multiply by 55 miles. So now, look at what happens when I cancel out my units. Inches with inches, feet with feet, and miles with miles. So if I do all this math, I'm just left with revolutions. So that will tell me exactly how many revolutions I've done when I went that 55 miles. So when you do all that math out, be careful with your parentheses. You want to make sure that 28 pi, you're dividing this whole top by this whole bottom. So your final answer should come out to be 39,616 rotations. Cool. Now, part B is a little bit different. So now B, you're going to take the same exact car. You're going to drive the same. You're going to drive with the speedometer reading the same 55 miles, but now you have 16-inch radius tires on your car. So, does that mean, are you still going 55 miles per hour? Are you going faster or slower? Because you got to think about what's happening with the car. The car is spinning I don't know, all the parts of the car, axle or something, whatever. So the thingy that's spinning the tire is going to spin at 55 miles per hour. But if you change the size of the tire, but you keep spinning it at the same rate, are you going to go further? Or not as far? I don't know. Let's find out, right? So I know that I normally go this many rotations, right? So what I need to do is now change these. I'm going to do dimensional analysis with this guy. I'm going to take those rotations and figure out how many miles I go with my new scenario. So I need to figure out my new circumference, because now I've changed the radius of my tires. So I'm going to pop in a 16 there. So my new circumference is 32 pi inches, right? Okay, so let's take the rotations that I was just doing. 39,616 rotations. And I'm going to multiply that by, well, in my new setup, one rotation will take me 32 pi inches. So if I were to cancel right now, I would know how many inches I go, but I want to know how many miles I go. So I got to change inches to miles again. So I have inches on the top, now I want inches on the bottom. There's 12 inches in 1 foot. There are 5,280 feet in 1 mile. And now if I stop here, let's check out the units. Rotations, rotations, inches, inches, feet, feet. So if I do this math correctly, it will tell me how many miles I've gone. Speedometer is still reading 55 miles per hour. I still drove an hour. Do I go 55 miles? Guess what? I don't. You are going to actually go, if you do this math, you get 62.9 miles. So even though your speedometer read 55 miles per hour and you drove for 1 hour, you should have only gone 55 miles. You didn't. You went 62.9 miles. So they're asking, well, it's not you, it's Terry, whatever. Does Terry deserve a speeding ticket? Yes, he does. Or she. I don't know. They should have only gone 55 miles, but they went further in the same amount of time, which meant they went too fast. So, yes, give them a ticket. Naughty, naughty. Okay. And then the last question was on this clock stuff. I love these clock questions. So here, again, you want to imagine that I know this is on a very small scale, but imagine that you were in Honey, I Shrunk the Kids and you were on this clock and you literally walked the path that the minute hand would follow in 30 minutes. So that's what 37 is asking you, 30 minutes. So it would go from the 12 to the 6. You're trying to find out how far of a walk is that. If you start at the 12 and you went to the 6, assuming that this is 3 inches long, right? Because if the radius changed, then that would change how big the circle is, and that would change everything. But on this clock, if that's 3 inches, and I'm going to go for 30 minutes, how far did I walk to get from one to the other? So this is another one where we're going back to that S equals R theta equation. I don't know. That's the length I would walk around the edge of a circle. That's what I don't know. But I do know the radius is 3 inches. And then what I need to do is I need to figure out from, let me switch to a pencil before I write all over this book. Okay, so if my minute hand is now down here, what is this angle in radians? I know it's 180, right? But you want to switch to radians. So if you remember how to do that, if you have 180, if you want to change degrees to radians, you just multiply by pi over 180. So 180s cancel, you're left with just pi. So that means that theta in that case is just pi. So the S is just 3 pi. What are my units again? Inches? Inches. That's it. Now 38 gets a little bit more complicated because it's 40 minutes. Well, guys, do you remember in like the very beginning of this class we did a clock problem? And so if it's at 40 minutes, remember we had figured out how many degrees each of these was? If you forgot, I'll just tell you. It was 12, right? 360 degrees around the whole circle divided into... Oh, wait. No, that's not right. Hold on. 30. Just kidding. Kidding around. Kidding. So kidding. So each one of these is going to be 30 degrees all the way around, right? Which makes sense because that would be 90. Yeah, duh. Okay. So anyway, if you're going to go from here all the way around to here in degrees, that would be 240. So we just need to change 240 into radians. And then we can pop it into this equation and be done. So 240 times pi over 180. Let's see, we could do 6 goes in, 4, 3. So it's 4 pi over 3. That's my, that's theta. So S equals R, which is still 3 inches, times theta, which in this case is 4 pi over 3. So the 3's cancel, so I'm left with just 4 pi inches for that one. Okay, so I'm going to let you try 39 and 40 on your own. However, just keep in mind, 4.5 hours, right? That doesn't mean that you're just, yes, I know that the minute hand will end up at the 6, but it wasn't just a walk from the 12 to the 6, right? In 4.5 hours, didn't it go 1 whole lap, 2 whole laps, 3 whole laps, 4 whole laps, and then another half? So be careful. You're going to have a big number in degrees, right? Because each one of these laps is 360. So you would add 360 4 times plus another 180 to get that 4.5. Okay? And then just change into radians and pop in the formula and you should be good. Okay? Hope this helps.